everyone. I am Dr. K. Prabhakaran, Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchengood, Tamil Nadu, India. Today we see that one important topic in our applied statistics course, the binomial distribution. The definition of binomial distribution: a random variable x is said to be follow binomial distribution if it assumes only non-negative values and its probability mass function is given by p of x equal to x equal to n cx p power x q power n minus x. The x value will become 0, 1, 2, etc. to n. Up to n value, this binomial distribution is a discrete distribution. Therefore, we countable value of our n. The applications of binomial distribution: the binomial distribution is a discrete probability distribution that gives the probability of getting exactly x success in n independent trials of a random variable. Here represent to x success and n independent trials is represent to and x value and n value. Each trial has only the two possible outcomes. So we know that the two possible outcomes here, one is a success and another one is a failure. We know that the success we give the probability name is the p, and failure name of the probability is called the q. The q is called, we represent the 1 minus p, also we represent in our binomial distribution. The conditions of this binomial distribution: a random experiment follow a binomial distribution if the number of trial is n is a finite and fixed value only. This is the main condition. We have here the countable of n value here, that is a represent to our finite and fixed. And next one condition: each trial is independent only. Each trial here only the independent, not a dependent values. And next condition: each trial has only the two outcomes only. Each trial has only the two outcome, means here success one, another one is a failure. We know that the probability of such p is constant for all trials. The probability of success here only the constant in the entire trials. So now the real-time applications of binomial distribution. The first one is we go to our quality control area. They are determining the number of defective items in a batch. We identify our defective items here. An example: the probability of finding defective thread in a sample of entire one lot of pack we identify. And medical and biological studies, we identify this binomial distribution, the success or failure of a treatment. The example: number of patients responding to a drug. So it was a new drug introduced and the hospital, we identify the number of patients with success of this drug is successfully used or not used, we identify. This is a main example here in our medical field. Then now the education and examination areas: the number of students passing or fail on an exam, the guessing answer in multiple choice questions. These are the trial and error method. Therefore these are the real time example quoted here, only this main three areas here. So now we see that our moment generating functions of our random variable of binomial distribution. So we know that the moment generating function of a random variable formula: mx of t equal to summation of x equal to 0 to n e power tx p of x. That's a p of x, means here represent to our binomial distribution. We know that our binomial distribution values, we know that n cx p power x q power n minus x only. So as it is e power tx in our moment generating function of definition. So now we will write in the summation of x equal to 0 to n e power t into p power x value, we combinedly will write in term of x. The remaining values we will write n c x q power n minus x. So now here we substitute our summation of values. We know that this case is our discrete case. We know that finite number of elements here. Therefore, the x value, starting value, we substitute the 0 on the equation p e power t on the power 0. And the anything power 0, the value will become the 1. And nc 0 value is a 1. And now q power n minus 0. Therefore, this time only we have the value. This value will 1 and this value also 1. Therefore, the first time we substitute here x value 0 means we got it the value only q power n. And now we substitute the x value equal to 1. p e power t, the power 1 is a p power t. And nc1 q power n minus 1. And next one we substitute the nct2 value p e power t on whole power 2 and q power n minus 2. And next one nc3 p e power t on whole power 3 q e power n minus 3 etc. We substitute and the entire n values. We got it the finally one simple formula. We know that q plus p e power t on whole power n. This is the moment generating function of our binomial distribution. This binomial distribution we are applying and determine here mean and variance of our binomial distribution. So we know that what is the mean means our e of x at the moment at the origin value is called the mean. The moment generating functions already we know that the mx of t equal to q plus p e power t on whole power n. So now derivative with respect to t at the first derivative at the origin value here determined. Therefore, we taking the derivative with respect to t, this value n into q plus p e power t on whole power n minus 1 into p e power t. At the origin means we substitute the t place we replace the 0. N into q plus p, anything power 0 is the 1, n minus 1, p e power 0 is the p. So we know that our entire binomial distribution concept value, that is a equality of p value 1 by 2 and q value 1 by 2 equal to 1. Therefore we substitute here q plus p equal to 1 and n into 1 to the power n minus 1 into p. We know that 1 power anything value is only 1. Therefore the mean value e of x value become only np. We identify the binomial distribution mean value equal to np. So now let us go to our variance value, how to find out. The variance formula we know that e power x square minus e of x on whole square. So what is a e of x square means the second derivative at the origin. The second derivative of moment generating function, the binomial distributions already we determined. Again we take the one more derivative, the p e power t n into n minus 1 q e power q plus p e power t into n minus 2 into p e power t. And we keeping n into q plus p e power t n minus 1 means again we got it the p e power t. So this value we substitute again at the origin t place we replace the 0 value. Before the first one I substitute here p e power t on the entire bracket values, and here also we substitute. We got it the only anything power n minus 2 q plus p equal to n minus 1. This entire value will become 1, and remaining here we substitute the t value 0 means we give the only p n into n minus 1 q plus p equal to 1 into p, and this one n into 1 into p. So now the simplify this value np into n square minus 1 into np p value. Now the multiply of this value inside the bracket p square n square plus np into n 1 minus p of or minus p into 1. So we write the both type, any one case we will write. And now we simplify this data, we multiply this value n minus p square, we cancel the both term n square p square minus p square n square. So now they determine this value the entirely balanced for e of x square equal to p square n square n p q. This is for our e of x square value. We know the formula e of x on whole square, this value. We cancel, we substitute here, we cancel p square n square value, wherefore the remaining value is only npq. We identify the variance value npq. This is the moment generating functional derivation of mean value np and variance value npq. Thank you for watching my video.